We are asked to find out Marshallian demand functions for u equals 2 x1 x2. Now this is a Cobb-Douglas kind, okay? So it is a Cobb-Douglas kind of utility function. And other thing is that about the Marshallian demand functions, what is important is that these functions, they are in the form of, say, x1 star is in the form of income and prices. Okay, that is our income and prices. So this is the form of the Marshallian demand functions. We have the utility u x1 x2 is equal to x1 x2. Suppose price vector is p1 p2, income of the consumer is m. So what is our budget line? p1 x1 plus p2 x2 equals to m. Okay, so it means the total expenditure is equal to total income. We are assuming that all income is spent and hence it is holding with equality. Okay, now in order to find out the Marshallian demand functions, we'll set up a Lagrange. So our objective function is this x1 x2 plus lambda m minus p1 x1 minus p2 x2. Okay, now the thing is, how will we find out the first order conditions for this? We'll find out the three partial derivatives, that is one with respect to x1, other with respect to x2, and third with respect to lambda. So del L by del x1 is equal to, say, x2 minus p1 lambda is equal to 0. Del L by del x2 is equal to x1 minus p2 lambda is equal to 0, and del L by del lambda is equal to m minus p1 x1 minus p2 x2 is equal to 0. So I hope that this is clear to you, that how actually I have derivated this, partially derivated this. As you guys know this very well, that this is like an implicit function. Okay, your x1 x2 is there, and both arguments x1 x2 is there, and we need to find out the change in only one of the argument, keeping the other argument constant, and this is what we are doing. So I'm derivating this x1 x2 with respect to x1, keeping x2 as a constant. Suppose if this x2 is 5, okay, then 5x1 deriv derivative would happen just 5, okay, and hence this constant out here. And similarly here, so you have just derivated this with respect to x1, and this is what you have got. Okay, so I hope this is clear to you. So just number these equations 1 2 3. Now dividing 1 by 2, what exactly you'll be getting? X2 by x1 is equal to p1 by p2. Now suppose your x2 is equal to p1 by p2 x1. Okay, so you will now substitute this x2 into the third equation. Your third equation would become m minus p1 x1 minus p2. In place of x2 you will write p1 by p2 into x1. So these p2 and p2 will get cancelled out. Of course, this is equal to 0, and what exactly will be left with? M minus 2p1 x1 is equal to 0, which in terms of x1 it would be equal to m by 2p1. So you can see this, that this x1, this is a function of income and this is a function of prices. Okay, just see this. So, and this is your Marshallian demand functions. Okay, now if you substitute this x1 out here, okay, you'll be getting p1 by p2 into m by 2p1. So this p1 and p1 will get cancelled out, and you'll be left with m by 2p2, and this is your x2 star. This was x1 star. So your vector of Marshallian demand functions is x1 star x2 star is equal to m by 2p1 and m by 2p2. So these are your Marshallian demand functions for a Cobb-Douglas utility function.